Check this out. We've got something really fun today. This is so amazing. Oh man, again? 2.4, the cosine law. We're going to derive the cosine law using this generic triangle right here. And there's no side lengths or angles on here, so this represents any triangle. First thing we're going to do is cut it perpendicular to the base. And that creates the height, h, and also side CD here will be called x, and this side DB will be called a minus x. Originally this whole side was a, so if we cut off x on this side, we're left with a minus x for side DB. Now for each of these right triangles, the right triangle here on the right, we apply the Pythagorean theorem. Do it again for triangle ACD on the left, we apply the Pythagorean theorem. We can take those two Pythagorean theorems and set them equal because they both have an h squared term and we don't want the h, so let's do that first. So the first equation here will solve for h squared. So h squared is equal to c squared minus a minus x squared. And then the second equation here, we're going to solve for h squared as well. So h squared is equal to b squared minus x squared. Now those two can be set equal and we can get rid of the h squared. So putting these two together, we got c squared minus a minus x all squared, and that equals b squared minus x squared. Now let's multiply out this binomial here and see what we get. A squared, remember there's a minus in front, so minus 2, that would be a plus 2ax, and this would be minus x squared. So on both sides we can add an x squared to get rid of this one and this one, and that's good because we didn't want the x's in this equation. Next, we have one more x here, and that's too bad because we didn't want that. So we can use this relationship. It comes from the triangle here. We see that from angle C, we have the adjacent over the hypotenuse. So that would be cos C equals x over b. So we can solve this here for x. So x would be equal to b times cos C. So we can replace that. So we get c squared minus a squared plus 2a, and then here's where we make the substitution. b cos C is equal to b squared. And that's actually successful. We got rid of h and x and made a relationship here. We're just going to rearrange this so it looks nicer. Let's put the c squared by itself on the left side. So we're going to add a squared onto both sides to bring it to the right side. The b squared is already over here, so just putting things in alphabetical order here, I'll put it like this. And this looks suspiciously similar to the Pythagorean theorem, except we've got this part. So when I move that over to the right, I've got minus 2ab cos C. But that right there is the cosine law. Now we wrote it like this. We labeled C, side C, and side A and B. There's no reason why it has to be written in this way. I mean, we could have labeled our triangle a different way. So just notice that side C is opposite the angle C, and we're not using angle A or B here. But we could switch this all around. So if you want, this could have been a squared equals b squared plus c squared. Then it would have been minus 2bc cos A. And that could work if you prefer. Or even b squared equals a squared plus c squared minus 2ac. Notice these two sides are the same ones we're squaring. And then this would be cos angle B. And any one of these three is the cosine law. We want to use the cosine law whenever we're interested in three sides and one angle, like this one. We want to find the missing side to the nearest tenth. So this would be angle C and this would be side C. So we will set up the equation like this. C squared equals A squared plus B squared minus 2AB cos C. C squared is just C squared. A squared could be 8 or 15. It doesn't matter. They're interchangeable. And then 2 times 8 times 15 times cos of 40 degrees. Now, the C is not interchangeable. This angle needs to be the opposite of this side. And we can put this in our calculator, and we get that we get 105.1493337, and a lot of students forget to take the square root. Now I want you to just look at this number for a second, 105. That does not look like a reasonable measurement for this side length. So take the square root of both sides, and we get that C is equal to 10.3. There's no units in this question, so we'll just leave it as 10.3. The next one has angle A, and it's missing side A. So I'm going to rewrite the cosine equation like this. A squared is equal to B squared plus C squared minus 2BC cos A. This time I don't have A squared or A, so I'll just leave that. Fill in B and C, and we can put this in our calculator. And should get that A squared is equal to 51,728.28. That's obviously too big, so we take the square root of both sides, and we get 227.4, and there's no units, so that's how we will leave it. For this one, we want to find the length of side B, but in exact values, not in decimals. So let's set this up. We have angle B here, and we have side B. So I will write this as B squared equals A squared plus C squared minus 2AC cos B. Fill in everything that I know. So I'll call 9 the A side, but again, it doesn't matter. It could be 11. And the angle B here is 30 degrees. Now the good thing about this question is we know what cos 30 is. So we can put all of these values in here. 99, and cos 30 is root 3 over 2. And I left a 2 out here so I could cancel it out there. And then we've got B squared is equal to 202 minus 99 root 3's. And take the square root. And I'm just interested in the principal square root. So I'm going to drop the plus minus and just do plus. And in this question we do have units, so don't forget the units if there is some units to be had. Two planes left an airport and they're flying in different directions. So here's my runway, and the angle between their flight paths is 47 degrees. 1 hour later, plane A has traveled 850 kilometers, and plane B has traveled 900 kilometers. And we want to find how far apart the two planes are at this time. So maybe a bit more, and we want to find this distance here. And this is 47 degrees. So I'm going to call this side A, and this side B, and this side C. But it really doesn't matter how you label this triangle, or even if you make a diagram. We've got C squared is equal to A squared plus B squared minus 2AB cos C. Fill in everything that I know here. 850 squared plus 900 squared minus 2. 850 times 900 cos 47. And I'm just making sure that the side that I'm looking for is opposite this angle here. Now I can put this all in my calculator, take the square root. I think I get something like the square root, the C squared is equal to 489,042. Okay, and take the square root of both sides because I know that's ridiculous for that distance there. and I get 699 kilometers, and that's a good measurement. That makes sense. In this question, we have two cruise ships leaving port at the same time. They're going in different directions at different speeds, and we want to know how far apart they are after 3 hours. So first, pause the video, try to draw a diagram of this situation, and then continue once you think you have a good idea. Okay, so hopefully you came up with something like this. I don't know if your port was on the bottom or the left, but anyways, here's the port and here's the directions they were traveling. We're trying to find the distance of the dotted line here. Now, just like in my other diagram, I'm going to label this side A because it corresponds with my cruise ship A, and this one B because it corresponds with cruise ship B. And I need the distance traveled. I'm only given the speed. So side A is equal to 30 kilometers per hour times 3 hours, and that means they went 90 kilometers. For B, they went 37 kilometers per hour for 3 hours, and so they traveled 111 kilometers. The last thing I need here to do my cosine law is this angle right here. So that would be 180 degrees for this straight line, and then subtract off the two angles that we know, 55 and 63, to find what's left here. And it's 62 degrees for their triangle. Now I can set up my cosine law, and I'm going to call this side C here. So my c squared is equal to all of this. Yeah, now I'm going to fill in the things that I know. So 90 squared, 111 squared, and cos of 62 degrees. Put all this in my calculator and take the square root, and I get that they are 105, and we went to the nearest tenth, so 0.1 kilometers apart. So far, every example we've been doing, we've just been missing this side here, which was really convenient because it was already solved for that in the way we first set this equation up. But now let's set the equation up if we're trying to find a missing angle and we have 3 sides. So just basically solve for A, or cos A if you like. So a squared minus b squared minus c squared will bring all of these over here. And then divide both sides by negative 2bc. And that will isolate cos A. So we could say that cos A is equal to, I'm going to use this negative and make this one negative and this one positive and positive. So let's do b squared plus c squared minus a squared all over 2bc. Now that looks pretty good. If you like that, that's fine. Some people even go a step further and say that a is equal to the inverse of all of that. But this is a bit messier to write, so most people will try to memorize at least this, or just use this and do the algebra every time. But this also works. Let's try that with example 5. We have all 3 sides, and now we're just missing the angle. So we can say that cos theta is equal to, remember if this is our A here, then our A is being subtracted, and you can see that it's unique. These two are positive and this is negative, and it goes with this. And then these two are on the bottom, and that's not opposite that one. Okay, so it's not hard to remember. This one would be one of these sides that's not opposite our theta, so 5. And this would be the other one, 22 squared minus 19 squared all over 2 times 5 times 22. Now we can put this in our calculator, we can take the cos inverse, and we get that in this case, to the nearest degree, theta is 48 degrees. Let's try that with this example. We have all 3 sides and we're missing theta here. So that will be my cos theta, and it equals 8 squared plus 15 squared minus 11 squared all over 2 times 8 times 15. And we can put this in our calculator, take the cosinverse, and we get that theta is equal to 45.6 degrees. Now we want to find side A here, and we're given side B, side C, and angle B. Now if you look carefully, this is a side, and an angle, and this angle is also acute. So if we were trying to do this using the sine law, then this might be that situation where it's ambiguous. But let's see what would happen if we did it with the cosine law. Now remember, this is the angle that I'm working with, angle B, so I have to set up my equation with side B on the side by itself. So I'll say a squared plus c squared minus 2ac cos B. Now fill in everything that I know. I know that B is 3.6. I don't know A here, and I know C. And I don't know A here again. So that's going to create an issue because then there's two of them. And then I've got cos 17 degrees. Now I'm going to rearrange everything here because this looks like a quadratic with a as our variable. Here we have an a squared term, and here we have an a term. So I'm just going to write it a bit different. 20 cos 17, and this will be a, and then all my constants. So 100 minus 3.6 squared would be 87.04. And now we've created this crazy quadratic with a trig in it. And that's okay. We can still use the, it doesn't look factor rule, so we can still use our quadratic formula. So a is equal to negative b plus or minus the square root b squared minus 4a, that'd be 1, ac all over 2a. I put this big huge mess into my calculator twice. Remember, once with the plus sign and then once with the minus sign. And I get two different answers. I get 11.7 and I get 7.5. And there's no units in this question, so those are the two different side lengths. Because I had a quadratic and it's giving me two answers. And then if we actually drew this to scale, then there are two angles because this is an ambiguous triangle. So here's our side 10, here's our side 3.6, and it can fit like this with an obtuse angle here or an acute angle here. So see, it's small enough, this side's small enough to fit right here and create this triangle. This was part of Trigonometry 3, solving problems using the cosine law. Here's some questions from the textbook. Give them a try. See if you know what you're doing.